for those that would like the last two examples, let's take a look at them, okay? If you feel comfortable not seeing them, that's your option as well. Okay, so again, the first step is I need to factor. So my numerator x plus 1, the reason I put in a bracket is it belongs together. X can't be separated because it is an adding 1 to it. Okay, the denominator, two numbers that multiply to give me 6, subtract to give me 1, largest one is negative. So we're looking at 3 and 2. And over to the second rational expression, two numbers that multiply to give me 12, add to give me 7, both brackets are negative. So we're looking at 3 and 4. And the denominator, this one, two terms separated by subtraction. Both are perfect squares, so therefore it's a difference of squares. Okay, next step obviously is to state our restrictions. So x cannot equal -2, +3, and plus or minus 4. Now it's a matter of finding terms that are in common so we can do some canceling out here. So let's take a look at x plus 1. I don't see anything I can cancel there. X minus 3 at the top here and at the bottom over on this one. X minus 4, x minus 4. And again, I look to see, do I have any other factors? No, I don't. So now what I can do is I can actually do the multiplying. So on the top I have an x plus 1, the bottom an x plus 2, x plus 4, and restate our restrictions. And the last question, again, it's not that it's any harder, it's just a longer. So the first step again is to factor. When I look at the first numerator, I can see I have a common factor of an x. The bottom I have two numbers multiply to 2 and subtract to give me 1. Largest one is negative, so we know that it's that. The next one, a difference of squares, x plus 1, x minus 1. On the bottom here we have common factor again of x. And let's go and look at this dividing. We have two numbers that multiply to give us 1 and add to give us -2. So we're looking at -1, -1. So actually it was a perfect square. And again, the bottom here, it's also perfect square. However, I am going to write them out, just makes it just a little bit easier when I'm actually canceling the brackets. So it's -2 and x minus 2. And our restrictions, x cannot equal. We have a whole list here. Let's go here. So we have -2, -1, 0, +2, +2, +2. So we have 2. Oops. We have 2, -1, and 0. And next step, when we are dividing, remember we have to reciprocate. So we need to reciprocate our last rational. And yes, you have to recopy this out. It's not going to kill you. It will use a little bit of ink, or it might use a little bit of lead. But that is not too bad. Oops, 2. Okay, at this point is where we flip. And I look to see whether this created some more restrictions, and you can see it has. Now what the problem is, well, it's not a problem. What we've created is another restriction. X cannot equal a +1. Now what we can do is we can actually go through and we can cancel. So we have an x here, x here. Remember, we can cancel diagonally. We have an x minus 2, an x minus 2, an x minus 1, an x minus 1, an x plus 1, an x plus 1. Okay, another x, and if you look, everything's been stroked off, which means it's 1/1. So our final answer is 1 with the restriction that x cannot equal 0 plus or minus 1 or 2. All right, so remember, if you can't cancel something after you have factored it, probably you have factored incorrectly. Okay, so if you need those examples, there's 2 more, and now I think you're set ready to do some work tomorrow.